Hey, folks, we got Joe Chacon back in town.
Hey, Adam.
Good to see you, buddy. It's nice to have you back in Tehachapi.
It's always a pleasure to be in Tehachapi.
Yeah. All right. What are you doing in town this time?
I am in town this time doing a thermal study with some software called ANSYS Ice Pack. So looking at our favorite thing, IGBTs, trying to make them run cooler. But before we do that, we have to understand the fidelity of our model. So we make a model in software, and we can validate it against real data. And basically, it's computational fluid dynamics or mechanical engineering, thermodynamics, stuff like that. Pressures, flows, volumes, stuff like that. But got to keep our electronics cool. So that's why I'm here.
Very cool. All right. I love that there's thermal software called Ice Pack that sorts out.
Yeah, ICEPAK. Registered.
Registered.
Yeah.
Pretty good. Okay. Back to thermal. Now, I remember one of our previous discussions, you said, Adam, it's always just a bigger fan or a bigger pump.
Oh my gosh. You remembered spot on. That was a PhD thermal engineer who told me his frustrations about all the elaborate things he had done, his thesis and everything. And he said it always boils down to a bigger fan or a bigger pump.
But managing how to do that is something else, right?
Yes. And it's a lot of fun too.
Oh.
I mean, you could really geek out on that stuff. Now, I'm not a mechanical engineer. I'm an electrical engineer. So I know enough to get me in trouble. So I have mechanical engineers that I use to help with that. I do a little bit, but I really rely on their expertise to do that. So in a way, it's almost like systems engineering, where you have to have cross disciplines. So that's called systems engineering. So the more disciplines involved, the more systems engineering required. So, but a decent electrical engineer and a decent mechanical engineer can work together, even with language barriers, communicate requirements, and get a good output.
And okay, systems. Let's just unpack that for a little bit, just to explain it to everybody. I feel like every time I talk to you, I want to like dumb it down so it's clear to me. But system meaning, okay, is this inverter, converter, or something like that? And we have electrical components that are being stressed thermally. They're getting hot.
Right.
Right. Now you need someone that understands some mechanics and flow of temperatures.
Yes.
To help out.
Yes.
Because you can't cool your electronics with other electrical components. Well, I suppose. Is a fan? Yeah, I suppose it is. So is a pump.
It's electromechanical.
Right. But help me understand why you needed the other people then to come in and.
It's a discipline in and of itself, thermodynamics. It's very complicated. As an electrical engineer, we had to take thermodynamics 1, and it was one I postponed as long as I could. It's been 30 years since I've been in school, but I remember the first time I took it, I dropped it and came back to take it in the summer session with the guy that wrote the textbook, and he was a great teacher, and I learned a lot. Many of us, when we say thermal, we think like a gas turbine or a steam turbine because they're thermal devices. You're producing heat to produce fuel, but I'm using thermal in the application of just cooling something or heating something or controlling the humidity or something like that. So many of the technicians who would watch something like this will easily know that there's a thermostat to control a fan, or a thermostat to control a heater, or a hydrostat to control a heater, which controls humidity. So those are all things that are mechanical, but everything works together as a system.
As a system. So you have a system engineer, electrical engineer, and a thermodynamic engineer?
You can, yes. Sometimes you could skip the systems engineer when it's not very complicated, but like a wind turbine, most people that design those, they're going to have systems engineers because you got a lot of components.
Mm-hmm.
You got blades, you got a machine head, you got towers, and they all have to work together. I had a boss who was the systems engineering manager one time, and he joked, and he's probably going to watch this and know exactly who he is. He said, it all works great by themselves, but when we put them together, they don't want to work. But that's what systems engineers do, and it's really can be quite complicated putting everything together. So in solar or BESS, you don't have as many moving parts per se, but there are still some systems dynamics that go on, and that role usually falls onto the EPC, engineering, procurement, construction team, to match everything up. So with panels or modules, tracking systems, met stations, soil stations, inverters, all that kind of works together. But like a wind turbine's a complicated thing, and a traditional power plant's even more complicated. So systems engineers make the world work like that.
Okay. So you got a hot IGBT stack inside an inverter converter. And you see it's air cooled, so you say, thermal guy, give me more air.
Yeah. So the things he or she's going to think about are like pressures and flow restrictions and things like that. So a lot of times you can relate what happens thermally to what happens electrically. So there's concepts for voltage and pressure and flow and current and things like that. So many times you'll look at a fan and you'll see a pressure curve. So you can ascertain where you're going to be on that particular pressure curve. But then when you go put it together into the system, you might have a restriction that you didn't necessarily know about. So in a wind turbine environment, you could, let's just say, you could be exhausting your air or bringing in your air that has a restriction to go with it. You just put something too close, right?
Right.
And it's not meant to. So when you test these things, like if you test a converter, inverter, in an environment, it's going to be open. All sides are open. Lots of fresh air is going to get to it. And this is true for water, glycol cooled, air cooled, thermos. It doesn't matter. Any type of cooling topology. That's why you want to replicate the conditions that it's going to go into before you do that.
Right. This would be like the inverter converter engineer saying, nope, there's nothing wrong with the calculations. The intake and the output are fine for moving air. And then you go, well, come look, because somebody put a wall next to you or something, right?
Yeah. So, and I think an example to this, like a technician who replaces an IGBT, slides it in, connects it, turns it on, and it doesn't work, or it works poorly. Send it back to the factory that remanufactured it or built it new. They put it under test and go, what do you mean it doesn't work? It works just fine, right? Well, it works just fine in their test conditions, but it doesn't work fine in the application at hand. I mean, there's all types of things that could be going on there. It could have been misdiagnosed. It could be the terminations. You could have all types of issues, and that's related to the system. So systems applies just as much to technicians who are working day to day as it does to engineers designing it, because you have to think, what else could be going on?
Mm-hmm.
Are you a part swapper, or are you a root cause person, right? From a technician point of view, it's real easy to swap a part, and then you go put it in, and it sort of works or doesn't work at all. And then you have to put on your system hat and think about that too.
Yeah, bigger picture.
Yeah, we all do, right?
We all do. This all right. And there's always answers. That's what you keep telling me. Like every time we've talked about a lot of different challenges with components and power production, and I don't think there's a single one we've talked about where you go, well, there's answers out there. There's solutions. A lot of time it's the price.
Yes.
That is the hurdle.
Yes. It's almost always the price. It just depends on, in our industry, I mean, it really boils down to the power purchase agreement. That drives just about everything. So when one looks at levelized cost of electricity, LCOE, the PPA drives the lion's share of that calculation. The upfront cost, it's a little bit too, and then the maintenance cost is a little bit, but definitely the lion's share of that is how much money am I going to get every month or whatever my pay period is by operating this thing. And then you get a systems engineer can make a decision. I'm going to run this thing as hard as I can, and I'll throw as many people as I can and just swap parts all the time because I want to get this thing running. Now, a true systems engineer is also going to consider safety. So safety is just as much important as any of the other disciplines as well. So you want to do everything safely. But, the only safe solution is to not work. So you have to balance that with what can we do?
It did not work.
Yeah.
That's the safest?
Yeah, don't do anything.
That's pretty good. We'd like to thank our sponsor, Altair Energy Services, and their highly trained, expert technical staff, leveraging decades of renewable power management experience into customized solutions for everyone to meet their energy goals and contribute to a better future for all. Altair's team of hardworking, respected experts are providing full-scope, turnkey repairs, planned and unplanned maintenance, system upgrades, fully autonomous technical crews, supplemental staffing, and customized dynamic scheduling to fit your power production needs. Contact Altair at info@altairenergyservices.com and learn more about their wide range of capabilities across multiple power technologies and platforms. I'm glad a thermal project brought you back to town.
I am too.
Yeah, that's pretty cool.
Yeah.
And it starts to, can we talk about, you taught me a lot about combiner box fuses recently.
Did I?
And it's thermal calculation. Can we talk about that?
If you want to, sure.
No, yes?
No, I won't talk about anything.
Oh.
Much to my chagrin, you like to be very extemporaneous, but let's do it. I just don't remember all the context, so help refresh me.
About extending life on fuses in combiner boxes.
Oh, yes.
Right?
So fuses.
I mean, these pop all the time.
Yes. So a fuse, a thermomagnetic circuit breaker. See, the key word there is thermal.
Yeah.
Magnetic. These devices depend just as much on they trip based off heat. That's ultimately the thermal aspect is what trips them, right?
Mm-hmm.
Because you're going to have to melt the sand and the fuse, or you're going to have to get the breaker to a certain temperature before it trips. So one could develop a transfer function for current, which generates heat. So what's current times resistance? Heat.
Okay.
That's I squared R. Okay.
Oh, okay.
Yeah. So you have heat, and let's say a fuse probably is going to dissipate probably 2 to 5 watts of heat, depending upon how big the fuse is. So when it gets up to 6-7 watts, and I'm just picking on, I'm throwing out round numbers just to make the math easy, the device is going to trip. And it's also going to create more heat inside the enclosure that also has to go with it. So when you put these in
compounds.
It does compound.
Okay.
But what really compounds even more, I was just doing something for an outdoor application not related to renewables, and I asked the engineer, they asked me for consulting, I said, have you considered putting a device over there to provide shade for it? And I haven't heard back from the engineer, but it's an application where reliability is much more important than cost, so I'm sure he's going to do that. But solar loading is quite a big deal. So you have emissivity. My tongue gets tied saying that, right? But the color of the device definitely affects how much heat it absorbs versus how much heat that the enclosure rejects. A white enclosure is going to reflect quite a lot off, and a black one's going to absorb more. Very common analogy is people know you don't leave small children or pets in a car in the summertime.
Yes.
Okay. So the car is not running. Why is it getting hot? Because of the sun. So the same thing happens in an electrical enclosure. So you're going to have anywhere between 600, 700, 800, up to 1,000 watts per square meter being absorbed into some enclosures, and it's not going to be able to dissipate that effectively. So there are some things that could be done to get that to work. And so natural convection is one. Putting a roof over it is another one, a little shade. If you think about being in the sun versus, have you ever gone to a sporting event and you're in the shade, in the sun, and then the cloud comes over and, you and your wife just go, oh my gosh, this feels so much better.
Yeah.
Well, that's the way our electrical components are too.
Yeah.
They want to be cool.
You're leaving humans and dogs in the car analogy. If we crack the window, we've changed the inside of that car.
What's going on?
Can we crack the window on the boxes?
Yes.
That's
natural convection.
That's natural convection.
Yeah, that's natural convection.
Okay.
So you have convection, conduction, and radiation. Those are your three primary functions of heat. So the sun's going to give you, all of them, of course.
Are there rules or regulations on how open you can make the window? You can't just take off the front. If you just, open the whole thing up, you've got a whole lot of airflow.
Mm-hmm.
There's got to be something wrong with that too, right?
Yeah. So UL50E governs the rules for set forth by the requirements from a systems engineer. I love how we're tying all this together. Your questions make it so apropos. So UL50E is the standard for the what we call NEMA designation. So NEMA is the National Electrical Manufacturers Association. So you give different designations based off on how sealed you want your enclosure to be versus how open you want it to be. If you want it as tight as a frog's butt, that's going to be like a NEMA 12 for an indoor application, or like a NEMA 4X. And then there's an IEC version, which is more European Asian. They give different numbers, two digits, like IP54, for instance, would correspond most likely to a NEMA 3R or NEMA 4. They just tell you things like corrosion, objects that can come in, dust, water, how much water. So we literally, when you're trying to declare something to be that way, you buy it from a catalog, but the people that certify these, they will take atomized spray nozzles and go out and spray them. And, there's no such thing as truly like waterproof or dustproof. So you allow so many grams to get in, and they'll go in and measure them and verify that that integrity is there.
I'm always amazed about how much you know about this and the stories that you tell to help me understand it. So, okay, you can't just take the front door off and let a whole bunch of air in, but you can open it up with some ventilation.
You could.
Can you?
Sure.
Okay. You have risk.
And that's where good systems engineering comes into play. If everything on the inside is rated for it, why not?
Maybe. I see.
Then why put it in an enclosure at all?
Okay. So,
I feel like we're talking systems a lot today.
You got the dog in the car. You crack the window to help the dog, but if you roll the window all the way down, you might lose the dog.
Yes.
Unless the dog is properly trained somehow.
Yes. Yes.
All right. See, sorry, I don't mean to go back and forth on you, but honestly, that kind of conversation, I think it really helps me, and I hope helps others understand too.
Well, we could talk about a renewable example, like latches on a hub.
Yeah.
Okay. How many people have you seen just take them off completely?
I don't know.
Lots.
Just take them off.
Yeah, I'm not proposing to do that.
Okay.
Okay. As an engineer, I'm not proposing to do that. But
Get airflow.
Yeah, but I've seen people just take them off because many times, and the impetus for this sometimes was they would forget to latch it, and then as it would turn, bam, 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 bam. So that's one reason, and so many of them just took them off, and
that's why they were flapping. I didn't know that.
Yeah.
Okay.
Yeah. So you want it to breathe, but you have to do things to. There are rules, and the rules are set forth by the system engineer, knowing that I sold a transformer to a customer in Hawaii, and he didn't know what he wanted. So he said, "Can you make it mongoose proof?"
Okay.
Because there's a lot of mongoose. Is that the right word?
Gooses?
Mongooses in Hawaii. And I go, "What do you mean mongoose?" He said, "They can find their way into anything, right?"
Okay.
So have you ever opened an enclosure and found a snake?
Sure.
Yeah. So they find their way into things. And that's because we do want them to breathe and move. But we also, so NEMA, UL50E governs how much we allow that to happen.
Okay. All right. Didn't mean to take it through a whole lot of systems engineers, but did mean to share with everyone that, there are options for them to reduce as many combiner box fuse failures, and give you a call.
Yes.
You showed me how that can happen and helped me understand it a while ago, so I thought it'd be fun just to share and say, call Padge.
Yes. Yeah. And I'm glad we didn't talk about our fuses required and things like that. That would take a whole nother episode, and I get really worked up about that. Sometimes I'd like to be on the standards committee, the fuse versus breaker debate, and that it's the National Electric Code gets politically influenced or commercially influenced by these different people that make different things for various reasons.
Well, appreciate you going down the rabbit hole with me and bouncing back and forth like the Pong game or something a little bit. But I thought that was, brilliant. Fuses are getting replaced all the time, and it's expensive. Not on the fuse. It's expensive on the downtime. It's expensive on the labor.
Yes.
So, small, inexpensive upgrades seem like a really good idea.
Yeah. $20 a day per fuse per combiner box is for a very light PPA.
It's very expensive.
Yeah. It's very difficult to detect, too.
Yeah.
Very difficult. So
right.
It requires a lot of human interaction going and checking that fuse.
Your scan gets you to the string. After that, it's the humans getting you the rest of the way, right?
Yeah. And then, if you're at a solar site and you're replacing fuses all the time, what else are you neglecting? What's your opportunity cost?
Oh, I see.
Yeah.
Could be spending your time somewhere else.
Yes.
Yeah. And, and then just to kind of tie it back to, there's always an answer to help improve reliability. You got to make a decision based on finances and economics. And that seemed like a really great one to me because it was low cost.
Yes. The one that I offer, now I don't put these in. I'm an engineer.
Yeah.
But we know companies that can put them in.
We know some people.
Yeah. The one I sell is about $500.
Yeah.
Yeah.
That seems like, one of the good ones when power plants are looking for the cost-effective upgrades to improve reliability and not break the budget.
Yeah. The ROI on this, including labor, is anywhere between 3 and 12 months.
That's insane for an upgrade.
It almost seems like a no-brainer.
That's a no-brainer.
Yeah.
Yeah. Okay. Well, folks, if you're looking for a no-brainer upgrade to your solar site, call Padge.
Yes.
You'll be on the phone for 15 minutes. You'll say yes and move forward.
Yes. And then we have to get somebody to install it.
That's right. And then we'll come up with the most economic way to do that as well.
Yes. I have a way to do it post-production. Obviously, the best way to do this is before you deploy it. But the solution that we have involves no cutting.
Yeah.
So because
I liked that.
Why would you want to cut into something and then scrap metal just gets thrown everywhere? Because then it could get in one of your fuse holders. You turn it back on and So our
It's a
solution
problem.
is no cutting.
Yeah. And we've done some upgrades to central inverters that required cutting. And it's a lot of containment of the shreds of material.
Yeah.
Yeah.
And that takes a lot of time to
Sure does.
build a barrier behind it, or sometimes you just take the door off and cut it somewhere else.
Right.
Yeah.
Yeah. Yeah. Or contain it. Okay. No, that's kind of where I was going. I wanted to tell people about it. And
Thank you.
yeah, call Padge, and can't find him, give me a ring. I'll connect you. Can we talk about your YouTube page for a minute?
Please. I'd love to.
Okay. All right. Joe has a YouTube page here. I'm trying to remember the names. At
Padge LLC.
At Padge LLC.
Mm-hmm.
Jake, we'll have to put that in there. And you've got quite a few videos. Am I seeing 14? That's the number.
We have right now 2 series, one on power quality and one on arc flash.
Yeah.
And I usually do these once a year in December, January,
Okay.
when things are pretty slow. And I enjoy it. I like seeing people learn and apply and take these things. And I learn a lot when I develop them too. So
I've been enjoying them. I mean, every time I talk to you, it seems like I got to listen or write it down a couple of times. I'm not an electrical engineer, you know? It's not as easy, but I do love that. I mean, I've replayed a few of them, and the other day I was listening to them, and then I was telling you earlier, I learned better yours by watching and listening. And I don't know what it was, but it's a lot of info. But I was really taking it in, and they're not long. You're giving out great info.
yeah, it's some of the ones I do, it's better to watch because I put a lot of equations, a lot of charts, a lot of figures, a lot of images.
Yeah.
And it's really hard to talk about engineering topics like arc flash, power quality, without the visual aids. Even if you're an auditory learner, I would still encourage people to visually look at it as well.
That is one of my hang-ups. I'm a visual learner.
Well, I think most people are.
Is that right?
Yeah, or kinesthetic, either way.
I'm going to play one a little bit, and I'm going to try and get it in here. Jacob, it'll come through probably, right? Yeah. But this last one where you said this putting it all together situation, and you put in some visuals, really helped me. I don't know.
Professional engineer in multiple states and have been an electrical engineer for almost 30 years. Please like.
Got to give the resume stats.
This important information in front of more people. This video is going to summarize everything we've examined over the last several videos. In video 1, I tried my best to emphasize just how serious arc flashes are, calling them radiant heat or letting the smoke
Joe, those
out,
are wild pictures. Like that hit me. And I'm like, oh man, I'm learning about serious business.
In video 2, I explained the minimum requirements for an arc flash label and settled the argument that you do need arc flash labels for your equipment and they need to be recalculated every 5 years. In video 3, we went through how NFPA 70E 2024 edition has really simplified personal protective equipment, or PPE. Remember, 2 categories of PPE, with the differences being very, very minimal. Face shield and balaclava versus arc flash hood, that's it. I like what they've done there. In videos 4 through 11, we went through several examples.
Wow. All right, I'm going to pause it there, but I think that gives everybody kind of an idea about what you're doing. And I think why I'm liking it so much is you... I got to put the microphone in front of me.
That helps a little.
Forgot about that. I like what you're doing. I think what I like the most about it is you're giving the, I don't know, all these codes and regulations and bits about engineering and the specifics on how things work.
Yes.
They go over my head often. It's tough. But then you break it down and you talk to me about energy levels and PPE and the importance of just understanding the label and the risk that's there. So all of a sudden now you got me. I understood. And, I don't know how many of the audience members you have are electrical engineers versus not, but I love that you break it down and explain it that way to me. and others.
Well, good. Thanks. The idea is to educate, keep people safe, and give a little bit of the background on where they come from, the equations. Most days, nobody does these calculations by hand, right? We buy software to do them, but every engineer should know where the math comes from, because if the software outputs something that doesn't make sense, you need to go back in and look at it and say, what's going on here? So with Arc Flash, it's going to be current, enclosure configuration, and time. Those three variables influence it the most. Okay. Prior to 2018, IEEE 1584 only focused on what we called the maximum power method, or Ralph Lee's original method, minus a few obscure coefficient tweaks, okay? That was mostly related to just current and time.
Okay.
Okay? So you want as little current as you can for as short as possible. So we focused on clearing times and things like that. The 2018 edition introduced lots of other factors related to the enclosure. Okay, the size of the enclosure, the spacing of the bus bars, the configuration of the bus bars. So for instance, bus bars can be vertical, they can be horizontal. If one's vertical and you have arcing energy, it's going to propagate in the direction of current flow, up or down, depending upon which way the current flows.
Okay.
Okay. And same thing horizontally. But now horizontally, that's projected out towards a person.
Okay.
So when you see these types of things, and they call it VCB or HCB, horizontal or vertical.
Okay.
Yeah. And there's three others, and then there's also the open air. But the open air is the one that has traditionally been used, that Ralph Lee developed in the 80s. That is a single point, and you have spherical energy being projected out, right? So substations are going to be like that. But when you put it in an enclosure, now all of a sudden, it's like a sawed-off shotgun, right? It's much more projected and projected at you.
Right.
Yeah.
So then you're also calculating information about the blast point?
Yes. So that's very important, because arc flash energy is always going to be given at a distance. And most of the time that distance is 18 inches.
Okay.
Okay. Why 18 inches? Because that's about the distance of a person's hand.
Oh, okay.
Yeah. So the idea is you're still going to get burned, but we're trying to categorize the severity of the burn and give the person working on that piece of equipment an option to put on the appropriate PPE to protect himself, right? Or herself. So it's important to, when you look at the label.
Yeah, let's help us with the label. Arc flash and labels, and maybe teach us how to read them a little bit.
Okay. The printer that we used was black and white, and we put a color cartridge in.
As good as we got.
We didn't have any to print. So normally, the way I like to do them is I do an orange background for a warning, and I trigger my software for anything less than 39.99 calories to trigger a warning. 40.00, I trigger a red.
Danger.
Yeah, which didn't print because it was black and white.
Right. My printer game is down right now.
Yeah. So that's the first one. And then we tell you that there are two hazards. There's arc flash and there's a shock hazard. So I typically, there's always a shock hazard for greater than 50 volts. And I use 120 volt as my threshold for arc flash studies. So I won't do 24 volts, although sometimes it's worth considering. I mean, if you've ever jumpered a car on a 12 volt battery and put them together, it can but
it can get hot.
yeah,
Yeah.
can make some sparks.
Yeah.
Okay. So then we give the arc flash boundary, and that's how far you must stand away before the incident energy drops below 1.2 calories per centimeter squared. Okay. So in this particular case, this is a 240 volt panel, 4 feet 5 inches away.
Wow.
Before it drops below 1.2 calories per centimeter squared. Okay. At 18 inches, this one is 6.7 calories per centimeter squared. Okay. So NFPA 70E has done away with the hazard risk categories that we often called Cat 1, Cat 2, Cat 3, Cat 4. They don't exist anymore.
Okay.
Okay. So, and this is in one of my videos, I think video 2, if I recall,
Okay.
where I explained it. They want to go off the number.
Calorie number.
Yes. That's why we do these. How many calories per centimeter squared?
Okay.
So we're not telling you a PPE category. So I'll put that in there, and then I will say refer to NFPA 70E 2024 Table 130.5G to see what type of PPE you wear. Because in 5 years, NFPA 70E could change, and I don't want to put something on my label that could change in next year or the year after. But I do know that number is physics-based and is not going to change. So I deferred that person to go there. And when you go to that table, you're going to see it's based off this. And they're going to have up to 12 what you to wear and 12 and beyond what to wear. So
Calorie.
yes. So that mystical number of 40 that used to scare a lot of people, and it still should,
Sure.
becomes irrelevant. So these are thermal risk. We often don't talk about the percussive risk, but there is also a percussive risk. Then I put this.
Can I ask some simple questions up here?
Please.
So 4 feet 5 inches arc flash boundary from where? Because I probably can't read that from 4 feet 5 inches away.
From the bus bar.
From the bus bar.
Yes. Okay. Now this gets really complicated on big lineups.
Okay.
Where you have service entrances and stuff like that. And I have a dedicated video just to explaining why I put one sticker per lineup unless there's other things in place for me to do that.
Okay.
And if I'm working with a client who needs more than one, we can do that, but there's a lot of assumptions that have to be understood before we do that. And the majority of people who see these in the field aren't going to necessarily know those assumptions unless you work on something very specific all the time.
Mm-hmm.
Okay. So usually this is going to be service entrance incident energy.
Service entrance. Okay.
Mm-hmm.
And then 6.7 calories. You've been good about giving me layman comparisons. Like, the big one was the Scud cruise missile, but
hundreds of calories.
What would you compare 6.7?
I'd have to think about that.
I thought maybe you had one. I didn't mean to put you on the spot.
No, I'd have to think about that.
Yeah.
I mean, it's going to hurt and it's going to put you in the hospital, and you're probably going to have some skin grafts.
Okay.
Yes.
More than 3rd degree in the hospital.
Yeah.
And they may not survive then.
Now remember, even 1.2, which is the number that doctors and others have told us that's where the arc flash boundary is, still it's going to hurt pretty bad. It's going to feel like major sunburn.
Yeah. Bad day.
Yeah, really bad day.
Really bad day.
Yeah.
6.7 though, I may not live, and if I do, it's not going to be a happy situation.
I think you're going to live.
Think I'm going to live?
6.7. But
Okay.
you're going to have some serious burns.
Yeah. Okay. On an arc blast. Okay.
Especially on your hands and whatever else is close to that.
Okay.
That's why, we always are going to wear FR clothing.
A lot of skin damage.
Yes.
Right. Yeah. Okay. Yeah, thanks. I'm
Okay.
going to put you on the spot, but try and make it real for folks.
Yeah. And then the shock hazard. So the shock hazard is different than the arc flash hazard. So For decades, we've all known about the shock hazard. But until the 1980s and 1990s, we really didn't think about the arc flash hazard. Linemen did and other people did, but it was never formally calculated. So now we have the LAB and RAB, the limited approach boundary and the restricted approach boundary. Basically, that's a qualified worker going in on an exposed bus bar, how far. And I think most people understand those. Mm-hmm. And then I tell them what type of gloves to wear based off that. And then I put the date every 5 years, and I put the name of the equipment. So this is a 240-volt panel in this particular instance.
Why is the 5 years so important?
Things change. So there's two requirements, every 5 years or on a major change.
Because things change. What things? Like
grid strength changes, for instance.
Grid strength.
Yes.
Okay, electrically things are changing.
Yeah, so there's settings can change. New equipment can change. Mm-hmm. Add-ons.
But if you didn't change anything about your power plant, you still have to do it every 5 years.
Yes.
Because things may have changed with the grid around you, influences that you can't control?
Yes. Yes.
Got it.
Yeah.
Every 5 years. So not just a requirement, but very important to keep people safe.
Yes. So this is a very basic one to do that's governed by IEEE 1584. And then we printed out one that is DC, which is still evolving.
Yeah.
Okay. We don't really know a lot about DC true incident energy.
Whoa. Scared me there a little bit.
Well,
okay.
Let me soften that a little bit.
Okay.
I think we're very conservative.
Ah.
Every engineer I talk to agrees that we're very conservative for. Many of us have seen DC arc flashes, and they are significantly less explosive than an AC arc flash.
Okay.
Okay. So with that said, DC shock is still a greater risk than AC shock because of the zero crossings of the sinusoid.
Oh, yeah. Okay.
So this can look really, really high.
Look at that, 14 feet and 104.7 calories.
Yeah.
That's crazy.
Yeah. This was on a combiner box, but it had a lot of things come into it. So remember I said that the enclosures come into place on AC.
Mm-hmm.
Okay. DC, to my knowledge, we don't really have any enclosure correction factors, gaps and things like that. We still go off the maximum power method.
Okay.
And it's very conservative.
Okay.
And, but with that said, until we figure out more of what's going on, it takes years to empirically derive all these things. They take them into a lab, they set up calorimeters, they create the condition, they create the arc flash, they record it, and then they develop these empirical equations. One of these, like this one here, has 13 coefficients just to get to an intermediate arc flash boundary calculation. It's crazy.
Wow.
Yeah, that's a lot of math.
All right. So this is on a combiner box?
I think so. It was a very heavily loaded combiner box. Oh, 2 seconds. That's what I was going to say. 2 seconds.
Yeah.
When there's nothing to clear it, most engineers will go with 2 seconds. So I always tell people who work on these things, put yourself in a position where you can get away.
Mm-hmm.
Okay. I knew a story of a gentleman who was doing something on his knees. You're not going to get away in 2 seconds on your knees, are you?
No.
No. So if you must,
I got to be positioned to move.
Get like a baseball catcher if you're going to get down low, right?
Yeah.
Yeah. Some people put a hook. Have you ever seen those?
Yes.
Yes. It looks kind of cheesy, but
yeah,
the idea is your reaction time, you can yank them away, right? And in the videos, I talk about getting some distance away from it. So we put on the label 18 inches, but I or other engineers can tell you what it would be at, let's say, 31 inches or 48 inches.
Right.
If you wanted to get some distance away from it. And it exponentially decays. So just getting further away goes quite a long way.
So can you walk me through how to work on this combiner box? If I say a scenario just for fun, I hope I'm not putting you too much on the spot again, but
sure.
You're the technician in the field, and this is on your combiner box, and you're tasked with changing out a fuse inside.
Yes.
How do you do that?
So I'm going to shut down all the equipment.
Okay. Tell us how.
How?
Yeah.
Well, I'm going to go shut the inverter down.
Yes.
How am I going to shut the inverter down? Remotely, if I can.
Yes.
Okay. So that right there, also when we do these, we put worst case. This is assuming everything is connected.
Okay.
Okay. So you got to actually, the label tells you worst case. You can actually go read the report. I put in the report working conditions and assumptions.
Yeah.
That get you there. So you go shut that down, and then you start isolating the different load break disconnects or combiner boxes, whatever they're called. So they all feed into a bus and then back to you.
Sure.
So you can have 2, 3, 4, 5 megawatts of connected DC energy all right there in that one combiner box because it's all interconnected. So you start isolating them. Next thing you know, you're down to 2 calories.
Right.
Yeah.
I gotcha. And, there could be some scenarios like that. But if I'm a manager of this solar power plant and I have my team of technicians, I'm going to write my lotto procedure for this box to include shutting down the inverter, aren't I?
Absolutely.
We're not going to go through and calculate what's on and what's off and start isolating bits.
Absolutely.
We're just going to shut down the inverter. This is the site policy. Here's the lotto procedure. We're all going to lock it up, sign it off, and then we're going to verify and go to work.
Yes. You don't work on anything hot anyway. There's very few reasons to do that.
But I have to make a nice, simple, standard procedure for the team to follow.
Yeah.
Yeah.
So there's 6 steps to Lotto: prepare, shut down, isolate, verify, apply your locks, and then control. I might have gotten them out of order. In fact, I
but
did.
I'm with you.
The most important step's the first one: prepare. That could take days, weeks. It could take developing an entire program.
Right.
But that's the most important step. And you need schematics. You need things like that. I was at an inverter recently where they didn't have schematics. And they were doing their best to develop a lotto program. And they had line side shock voltage going to various places. And the lotto procedure was to open the main breaker. Now, that may be fine, but you want to know where all your shock hazards are and what you're working on. And that's why I'm saying, if you don't work on something all day, every day, and you don't know where other sources are coming from, you do need to be very careful. And the verify step gets pretty important, and the prepare step's even more important.
Yeah. I remember you telling me a story last night. So that prepare step comes into place. You said you don't have the schematics. I mean, that's a stop work event to make sure that you're preparing in other ways if you can't have them. But then it's, do I have the right procedure and process, and can I follow it?
Yes.
Right.
Mm-hmm.
Yeah. No, that's difficult. And as equipment gets older and ages, and even newer stuff for odd reasons, but there is equipment out there you might not have schematics for.
Yes. In solar, there's quite a few. Many people don't want to ship schematics for confidentiality reasons.
Yeah.
I think at a minimum, you should give a customer enough to perform lotto. You don't have to show how you design the gate driver circuit card for your IGBT. But if you are bringing off a piece of energy from something that most people would ergonomically think is isolated, I think you should communicate that, overly communicate it.
What's Up Renewables is growing, and we're looking for new sponsors to join us. Our show connects leaders, innovators, and field professionals across the renewable industry, and our sponsors are part of that conversation. Some have seen their network expand instantly. Others have grown revenue and brand visibility through the connections they've made right here. If you want your company to reach the people driving the future of clean energy, now's the time to get involved. Contact us at media@whatsuprenewables.com to become a sponsor today. Thanks for the lessons. Your videos and explanations like this are needed more and more because, and specifically in solar, that industry is just growing like, I don't know, hula hoops or something.
It is growing a lot.
Yeah.
Best is growing too.
Mm-hmm. And a lot of people, yes, more high voltage, more electrical risks in both those places.
Yeah.
Yeah. All right. All right. I always feel like I'm picking on you a little bit, like asking for this extra information every time you're on the podcast, but
not at all. I'm happy I can recall some stuff, but
you got a lot of cool information to share. And
I'm just old. 3 grandchildren now that all call me Padge.
Yep. All right. All right.
And you have a grandchild.
I'm not far behind you. I do have on your heels there.
Yeah.
On your heels. Yes. I'm a grandpa now. And boy, loving that.
I am too.
Something funny about I never really thought about having grandchildren in my life. Yeah. Okay. Well, my wife. She's been wanting. I do hear people talk about wanting grandkids someday. And for me, it just wasn't ever a thought.
Yeah.
And then, holy smokes, there he is, and I just find myself staring at him in amazement. Like, I just can't hardly look away.
Yeah, and he looks just like you too.
Yeah. Yep. Yeah, Colton and I look a lot alike, so there's another one coming along. Yeah, that's for sure. That's really fun. Appreciate that. All right. Well, what's next? Where are you going from here?
I'm going to a solar site in the morning.
Oh, yeah.
And then going to meet with a customer tomorrow and then back home. And I'm about as busy as I've ever been these days.
That's what you were saying.
Yeah.
All right. So here I am trying to drum up more business for you. Mm-hmm. But is that what are you looking for? What are you wanting to do with Padge? Keep growing?
Yes, I want to keep it engineering focused.
Mm-hmm.
So I do enjoy arc flash studies. I do enjoy power quality studies. I do enjoy thermal studies. And I also enjoy doing new engineering for new construction or repowers or stuff like that. So those are a lot of fun. I can't keep up with the states that we're in.
You don't even know how many states you're licensed in? It's that many?
I can't keep track. But my wife's got a list, and she keeps track of it, and everyone is different. All the requirements are different for the licenses, for the business license and everything. So, but that's all important for arc flash studies, anything I need to stamp that's required. So new construction. I do like those. I'm not tomorrow going to go out and go bid a substation or a 100 megawatt solar site or anything like that. That's not. But if somebody has a single inverter that needs to be replaced, I can do that. Mm-hmm. Or if you want to do, I'm doing a test lab.
Yeah.
Yeah. Just putting in power for that. Trying to drum up, do all the civil work that's required and everything. I'm not there yet. Maybe. I don't know.
Right.
But, my son is starting at Clemson. So, in 4 years, I've had quite a few interns over the last 2 years. Got to pick their brain a little bit. It's exciting to be what I would call it like the peak of my career, maybe. I don't know. I don't know the future.
Sure.
But I do care very much about the next generation. I wrote the children's book for that. I'm doing the videos. Obviously, my passion is definitely about seeing the next generation. I was at a site yesterday I think I brought the average age up to to 31 probably. Um, these people in the field now just make me feel old.
Yeah.
But they're bright. They're doing great things. I'm so excited
For sure.
about this next generation. And that's a huge passion of mine. So, so I want to grow the company as a means to bless the next generation. But I don't want to work myself into a hole either.
Right. Okay. The passion's there. Big heart. And then you probably look for the right help, or it sounds like you're starting to develop maybe some of the next people for Padge.
Yes. Yeah. I contract out a lot of engineers and a lot of interns, but they're all 1099s. And it's seasonal. Very seasonal. Like from Thanksgiving to February 1st, I really don't have a lot going on.
Okay.
Yeah. So trying to maintain a payroll during that time period, just everything every business owner knows about.
Yeah.
So when I worked for large companies, we would often say, we need to hire more people. Well, the decision to hire a new person is a very big decision because that's a person's life. And it's also, your life, and you want to be respectful of both the person you're hiring and you and all your other employees. So I want to make sure we grow right and sustainably if we go in that direction. So probably my next hire would be another professional engineer or somebody with the EIT.
What's EIT?
Engineering intern.
Okay.
So you graduate 4 years from an ABET accredited school, then you take the first test, which is the EIT. It's an 8-hour test, I think it used to be.
Wow.
And then you practice under an engineer for 4 years, and then you take the PE test. And then you jump through a bunch of other hoops administratively. Some states you give fingerprints, and then you get your PE.
That's quite a career path.
It is.
That's a commitment.
It is. So you're 20, it's like a doctor, you're 26, 27 years old before you're off on your own doing it.
Yeah. Are there people pursuing this career? Large numbers? Are we?
No. There's not many. There's a lot of civil PEs. Civil stresses it more. Electrical PEs, just not as many for whatever reason. Not as many mechanicals. But if you're doing architect and engineering work, you do need a PE. Yeah, to stamp a drawing for arc flash, you're going to want a PE.
So not as many PEs or electrical engineers chasing it.
Correct.
Did I hear that correctly?
Yes.
Okay.
Civil, it's a must. If you're going to be a civil engineer, you're going to be stamping drawings.
Yeah.
So many electrical engineers go to work for a large company where it's just not required. If you're working on gas turbines as an electrical engineer, it's just not there. But if you're the EPC, then yeah, it's required there.
Right.
Stuff you're submitting to the authority having jurisdiction, AHJ, the inspector.
Okay. But there's still plenty of schools out there to go chase this career path.
Yes, and you want it to be ABET.
Okay.
ABET. So not every electrical engineering degree is ABET.
Is this an accreditation?
Yes.
Okay.
Yeah. I don't recall what the ABET stands for, but it's an accreditation standard.
Okay. We need more.
I think so. And AI is not taking that role. And
No.
I was talking with an engineer last night. AI is a friend of an engineer. You still have to write the request. It's like if I wanted to do a piece of MATLAB code real fast in ChatGPT, it's a piece of cake, right? But I have to be able to write the requirements to do that. And I have to be able to interpret it and I have to make sure it makes sense, right? And that was always been the case. Whether it's 1999 and I'm doing a piece of software, I'm still checking myself or whoever else to make sure it makes sense. So AI hasn't changed that one bit.
No. AI is an okay assistant.
Okay, that's really good.
I think that's where my head is with it. Like, it's helpful, but it's okay.
It is.
I'm not giving it a promotion, but I'm not firing it either.
That's true. I'm not firing it. I'm definitely not promoting it.
Right?
And I use the paid for models to help. They help with just basic administrative tasks the most. There's still the engineering stuff. It's just not there. I can look for typos. Heck, it makes typos.
It makes typos. Yes. It makes grammatical.
Lots of them.
Like sometimes I'm blown away on the errors it makes. But anyway, and sometimes I find myself asking, do you really think that makes sense? And I went, oh my gosh, I just asked the robot.
You asked the robot.
And I just walk away from my desk going, that was too much, Adam. We're going to get away.
Yeah. It felt like we're talking R2D2 or C3PO.
Right. That's right. Okay. Well, I love that your passion is for promoting, yes, in our industry for sure, renewables, but then also more specifically electrical engineers. You said 4 interns, and that's investment in people's careers too.
It has, yes.
Yeah.
I hope they do well.
Yeah. And that decision to hire and when to hire, I don't think ever gets less stressful in life. I've always feel it. It's that person's life, but you just came out and said it. It's that simple.
It's better, and if you're listening and you feel like you're overworked, it is better to work at 120% than bring somebody else, and then the two of you have to get let go because of financial reasons. So being a business owner, you have to make the money work, and the decision to hire is not taken lightly. And just because somebody's overworked, it's not always a good reason to hire, is it?
No.
It's like, just bear with me another year, and then if we keep this work, then we'll get somebody else. But then you're in the next year, and you're like, just keep this up, right? So that's always going to be the case. That's a good business.
Yeah.
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 I was telling the gentleman recording, he was telling me he's busy. I go, it's better than sitting around eating bonbons, right? Being busy's good.
It is good.
Yes.
It is good. I have that balance, which, I'm guilty of not having too much. But, I think about it a lot too. We're 3 years old here and scaling still and desire to grow. And some of that is desire to see people's careers continue to flourish and grow, right? Giving them that opportunity. So you have to match that supply and demand. And often you just need to sort of come up with the right strategy so that they happen at the same time, which is nearly impossible. So it's this, bandwidth of error that I kind of go with on making that decision.
If you're going to cheat, you're going to cheat to working more,
Yeah.
And I know you and Altair, you probably heard this expression, the 9-to-5 job just wasn't for me. I want the flexibility of working 100 hours a week, right?
Yeah, that's right. That's right.
What an oxymoron.
Oh my gosh.
But that flexibility is built in. But when you think about it, you are affecting lots of people's lives, not just your own family. And that I know you take that seriously, and I take that seriously. And if a business owner doesn't take that seriously, shame on them.
Yeah, no, what opportunity I can give other people for their careers drives me. It's probably one of the largest things that drives me. I think about how thankful I am for the opportunity I had.
Yeah.
And I'm like, I got to give that back. And oh my gosh, it's so hard.
Oh, yeah.
But that is the core of what pushes me.
Yeah. We worked with some great people at our former company. And people ask me, what do you miss about that? The people. Just everybody poured into each other, invested, and there's a lot of good people there.
I still network with a lot of them and keep them as definitely friends, but then also, folks that I go, ask for some help. I'm struggling with this decision. What do you think? And so many of them are just always there to help.
Yeah, a lot of good people.
Amazing. Yeah, really lucky to have that network. I'm just thinking about how much I've done it already this year. We're just into what are we, 4 months into the year in May, and this has been the biggest year so far, the biggest 4 months where I've had to ask for a lot of help, and everyone's been there.
Wonderful.
Yeah. Yeah, I hope it's like that for all of them as well. All right, got a little sappy there, but we built some good friends.
Yes.
Yeah. Yeah. And at this point in our careers, it's hard to chuck a rock in any direction and not find a friend.
Yeah. Everybody I work with, customers, yourself, most people want to do the right thing and are just eager to see the technology get better, develop people. You surround yourself with good people. We all build each other up. That's just as important as the business. If you ever get a chance, look at Clifton Strength Finders.
Okay.
Clifton Strength Finders. I'd recommend doing it as a company as a whole, because the premise says that many of us, we try to make our weaknesses better. It's very difficult to, something that you're innately not gifted to do, to develop.
Mm-hmm.
So there's 34 strengths that you take a test, and it's not a personality test. It's more like innate who you are. It kind of sounds like personality, but you got temperament and things like that come with psychology.
Okay.
But you have 5 to 10 things that you are really good with. For instance, my number one is called ideation.
Oh.
I'm really good at coming up with ideas.
Mm-hmm.
So, I mean, and I got to think about it. It's like I have 12, 13 patents or something like that. I'm not really sure. But that's a sign, a closed loop feedback, that I do like coming up with ideas, solutions. I mean, you've called me, and I feel like I can give ideas, and it's like, no, you don't want to do it that way. Do it this way. Yesterday, I was with somebody in his lab. It's like, no, you don't want to do it that way because the inspector's going to ding you. Let's do it this way. So just ideas.
Right.
Empathy is one. Harmony is one. Competition is one.
Okay.
So these different strengths, and you work to your strength, and you focus on getting that strength better.
Yep.
Like significance is my 34th.
Okay.
Yeah. But it's like my wife's 6th. And it's a strength, and I just can't relate to that at all. It doesn't make any sense in my brain, but I don't need it to.
Right.
Yeah. She's there. She's on my team. I'm on her team. It's good for her. So when a company or a family, knows their strengths, they're able to work together better. And you realize, okay, I'm not good at that, but you are. So how can we move the ball forward collectively with our strengths?
Right. Yeah. Capitalizing on the team's strengths.
Yeah. I think Gallup bought Clifton out.
Okay.
They're famous for their polls.
Gallup?
Gallup. Yeah. It's called Gallup Clifton Strength Finders.
I'm going to put this in so I don't lose it later.
My wife is a business coach, so she's always fascinated with these things. And we went to a marriage conference recently where we went through strengths as a couple. So that's why it's fresh on my mind. So Relator is also in my top 5. It's like close one-on-one friendships.
Yeah.
I bet you that would be one of yours because you do podcast one-on-one.
Could be. I'm going to take it and tell you.
Yeah, I'd love to know.
I know it's, yeah. I was making the joke last night. I'm back to a third grader's feelings wheel.
Yes.
to communicate properly lately.
Me too. Yeah, empathy's probably very low on both of ours.
I've gotten to this point, it's just a lot of busy.
Yeah.
Right. So feelings somehow got low priority.
Yeah.
Yeah. So Steph made sure. All right, let's talk about that. Yeah. Okay. I'm going to take that one. That'll be fun.
Yeah. To get your wife to do it too, because it's
right.
really good. Any type of organization where you have 2 or more people, because then you don't have to, and it's not an excuse to say it's my weakness, but we're all different. We're all made different. And I don't mean this to be a slight on anything, but in my opinion, it's the true meaning of diversity, equity, and inclusion.
Mm-hmm.
Is you have to go deeper And looking at strengths is a way to truly do that. Truly do that, I think.
Truly do it.
Yeah.
Right. I agree.
Yeah.
And getting to know those people.
Yes.
Right. First step, get to know yourself.
Yes, that's true.
Take the test. All right. Thank you for that. I'm going to do that. All of those extra personal, interpersonal pieces of education make us stronger and better people.
Good deal.
Yeah. All right, Joe. Thanks for coming and doing the podcast again. And it's very cool having you in town.
Thank you.
Safe travels.
Thanks. Bye-bye.